Welcome back, Physical Science 20. So this next example is the one I left you with, and it's kind of an easier one because it turns out to be a 1-to-1 ratio here, so it's a little bit easier. So if you look at part A here, figuring what the limiting reagent is, again, if I start with one of these, 2.3 moles of nitric acid, 1 requires 1. Let me just move up here. So 1 mole of nitric acid requires 1 mole of sodium bicarbonate. So if we figure that out, of course, units cancel, multiply by 1, divide by 1. Hey, we get the same result here. Or looking at it vice versa, if I was looking at, okay, what if I had tried to use the 2.0 moles of sodium bicarbonate first? It's 2.3 moles of sodium bicarbonate. And of course, 1 mole requires 1 mole. So 1 mole of sodium bicarbonate requires 1 mole of nitric acid. Again, the units cancel. Hey, and we get the same answer here. Now, we didn't have to actually go through that. You should likely have a statement saying that it's, oh, since it's 1-to-1, whichever one is going to be smaller, of course, is the one that's going to get used up. So if I try to use up all of my nitric acid, I need 2.3 moles. Do I have it? No, I don't. I have 2. So that's not going to work, which means this one has to work. If I'm trying to use up 2.3 moles of sodium, or sorry, I guess this is 2. My mistake. I actually only had 2 here. So if I try to use up 2, I need 2. So if I try to use up all of that 2, oh yes, I have way more than 2 here. I have 2.3. So this is the one that's going to work. And of course that is going to be my limiting reagent. So therefore sodium bicarbonate is the limiting reagent, since all of the 2.0 moles is used up. And of course, HNO3 will be excess, since only 2.0 moles of it is used up. Okay? So yes, we can see that, yes, we use up all of that sodium bicarbonate. 2 uses up 2. So yeah, you can see I'm going to have extra nitric acid left over there. So that makes it a lot easier when it's a 1-to-1 ratio as opposed to a different than alternative than a 1-to-1 ratio. So B here, let's see, what does B say? B says determine how much water is produced. So we're asked to figure out how much extra of this. So since we know that this is the limiting reagent, that's the one that we're going to be using in that calculation there. So we have 2.0 moles of sodium bicarbonate. And according to this, let's see here. Again, look at that. It's a 1 mole to 1 mole. So we know what's going to happen there. 1 mole of sodium bicarbonate is going to make 1 mole of H2O. So yes, the units cancel, but hey, the numbers are going to give us the same answer here. 2.0 moles H2O produced. All right? And lastly here, determine how many moles of excess remains. And yeah, this is fairly straightforward. We use up 2.0 moles of HNO3 here, but we were given 2.3 moles of it. So yeah, we know what to do there. 2.3 moles of HNO3 was originally available, but we only needed 2.0 moles of it. So that's how much was required. So of course that's going to give us 0.3 moles excess HNO3. So here you have it. That's example 1. Or example 2, sorry. So we'll do one more example here in terms of moles to moles. So the third one, if you want to pause the video, you could and simply try it yourself. I think there's one little issue here. This should be a plus sign there, so I'm not sure if your sheet had that or not. So chlorine can be produced in the lab by reacting hydrochloric acid with manganese 4 dioxide. A reaction occurs when 5.2 moles of hydrochloric acid, and this should be a plus sign here if your notes show it like that. 1.5 moles of MnO2 are both available. So this one's a 4-to-1 ratio, so it's not quite as evident as in a 1-to-1 ratio. So determine the limiting reagent. How many moles of chlorine will be produced? And then, of course, figure out what's excess. So if you want to pause the video, go ahead and try it. Otherwise, if you've already done that, let's run through that. So again, we'll pick each one of these to see what's going to happen here. So A, 5.2 moles of HCl, and according to the balanced equation, 4-to-1. 4 moles requires 1 mole. 4 moles of HCl requires 1 mole of MnO2. So of course, these units cancel. 5.2 times 1 divided by 4, that's going to give us 1.3 moles of MnO2 required. Okay, and we could look at that and see if that's going to work. But hey, let's just do the second one too here, just so we have both of them to compare. If I had started over here instead, 1.5 moles of MnO2, 1-to-4, 1-to-4. 1 mole of MnO2 requires 4 moles of HCl. So 1.5 times 4 divided by 1, 6.0 moles of HCl required. So now we can kind of take a look at which one works. So if I'm looking at this, 5.2 moles, if I try to use up all that 5.2 moles, I need 1.3 moles of manganese MnO2. Do I have it? Yes, I do. I have more than I require. So that is going to be the one. We can look at this one to see this one shouldn't work. If I try to use up all the 1.5, I need 6 moles of HCl. Don't got it. So that is going to be X marks the spot for that one. So therefore, I'm going to be using up all of the HCl because that's the one that works. So therefore, HCl is the limiting reagent, since all 5.2 moles will be used up, and MnO2 will be the excess reagent, since 1.3 moles is used up. Okay, so now that we know that HCl is the limiting reagent, so that's going to be my limiting, and of course this is going to be my extra or my excess, so it's the limiting reagent I use to figure out either Cl2 or H2O. In this case I'm here to figure out Cl2, 4-to-1. So looking at that, 4-to-1. So my 5.2 moles of HCl, and the ratio of moles of HCl to moles of Cl2, moles of HCl to moles of Cl2, sorry, 4 to 1. 4 to 1. So of course units cancel, and I get this, it works out to be the same number as the previous answer. 1.3 moles Cl2 produced. And of course, lastly, looking at how much of the extra is left over. So according to this, when I try to use up all my 5.2 moles of HCl, I only need 1.3 moles of MnO2, but I got 1.5. So 1.5 moles of MnO2 available. Subtract 1.3 moles MnO2 used, so of course I'm going to get 0.2 moles excess MnO2. All right, so with these three examples that we worked through, you should be able to do the first two questions from the assignment FC3.4. Then we'll come back and look at gram to gram limiting reagent questions, and that'll help you do questions 3 and 4. All right, we'll see you in a bit.